Yeah, when I looked at the EC2 dashboard, there was like I think close to 100 instances.
Yes.
Some were like M4 large, some were like T2 small.
That's just crazy, right?
And then there's zero documentation.
Yeah. That's just
With very crude implementation, we were rolling it out to an event in Australia, and then we were expected to have around 1,000 to like somewhere around 5,000 listeners at once. And I'm gonna send it to AWS Transcribe and Google Speech to Text for transcription. So the problem is now you are having charges occurring from two ways, right? You have to pay for your instances and the transcription node, picking up the chunks from the S3 bucket, transcribing and putting it into our Elasticsearch index.
okay. How did we manage Kubernetes?
Not Kubernetes. If you are watching this and if you are trying to think whether you need to use Kubernetes for your application, probably not. I think that's like the number one thing. Hello and welcome to the second episode of the 2 Bits podcast. I'm Manujith. I'm the Chief Operating Officer of Avantrio, and we have Lahiru, the Chief Technology Officer of Avantrio. At Avantrio, we do applied machine learning solutions, and we've been doing product engineering and applied ML for the past 4 years. Today, we are discussing one of the areas we have recently worked on quite a lot, maybe thanks to the pandemic and then the need for real-time collaboration and remote teams. So recently we've been working a lot with real-time technologies, real-time audio and real-time video, real-time user interactions. And today we are trying to dissect and see the different engineering problems and the solutions we have come up for real-time audio streaming as well as transcription. So when we think about real-time audio streaming and transcription, I think usually when we think it has two different things, like streaming itself and then transcription itself are two different things, there's like a number of solutions out there in the market. If you want to go with streaming, there's like hosted providers, there's like on-premise providers, there's a lot of space.
Yeah, managed services.
Managed services and all. If you want to think about transcription, there's again like Google text to speech, AWS has its own thing. Like there's number of solutions to address this. But if you want to do both together, I think there's a unique engineering problem when we try to put both together.
Yes.
So in this specific instance, we for this specific case study, we had a requirement from a client where they wanted to do real-time streaming and transcribing from audio sources, different audio sources, including their own apps audio source, as well as real-time live radios, like BBC, CNN, and radios like that. So for this particular use case, our idea was that we have to transcribe and put it into a real-time search index, something like Elasticsearch, and then allow people to search from it. But I think the same technologies, the same infrastructure have other applications as well.
Exactly. So I think the very unique application here, or the unique aspect of this particular use case, is that the transcription had to be available real time, right? I mean, you can do the real-time communication and the transcription real-time, but made the transcript available real-time and make it searchable was the challenging part here.
Correct.
So in this particular application, it was a consumer-faced app where people can come and find various sources. But we thought this could have more domain-specific other applications, and that's why we thought it would be useful to discuss this, because most of you would find other applications of this. So one of the applications I can think about is in the investment domain, because investors, or rather day traders, they rely a lot on live data.
Yes. Yeah.
So I think they take decisions based on different kind of live streams like news and podcasts. So if a certain company is being discussed on a famous podcast or a news channel, the stock value can get affected.
Yeah.
So because of that, this would be quite useful to take all these streams in, put it to a live index, and maybe even connect a GPT model and summarize data.
Yeah.
So that they can monitor it and make decisions based on that.
I think some of the part of the Bloomberg's terminal offering is exactly this. Like
exactly.
They provide real-time, on-time updates on the financial markets, just giving a terminal for you.
So you take our solution of a live transcription index, and then take the Bloomberg model and put it together, and boom, you have this crazy assistant for data reading, especially. I just thought of something else. So we have a lot of streaming platforms, news platforms where people come live and do their streams. But it would be helpful to do like certain things like profanity filtering and
in the
monitoring.
Yeah.
So if someone is violating the platform policies and going against the platform or the community guidelines, you can monitor it live using a search index and maybe a customized language model, and detect them and take them down without doing more damage.
Right. And you don't need the manual moderation or manual people listening to the things to figure it out.
That's not going to scale well with the input.
So when we got this challenge, I think now we have to think about when you mentioned that this can be applied into platform. There can be hundreds of thousands of users communicating in real time. So it is not just a one-way communication just three people having a conversation. It can be a broadcast where one person is broadcasting and then another 10,000 people is listening.
Exactly. If it was a couple of people just connecting to each other, I think the use case would have been, the implementation would have been rather straightforward. Yeah.
So considering this, I think we can boil down the key engineering challenges we face. One thing was making sure it's scalable. Scalable in the sense the platform should be able to scale to any number of listeners and broadcasters, as well as it should be doing so in a cost-effective manner. Because we all can build systems that scale indefinitely, but it's not the case that we are building it just to make it efficient. We have to also make sure that whatever the product don't go bankrupt as well. We have to manage the costing aspect.
So that is a big part of engineering in general, right? Cost management.
Yeah. So when we got this problem, the first thing we did was to be exact, this particular product has been in the market. The MVP has been in the market for some time, and then when they come to us, they were already once been bankrupt by the amount of AWS bills they have gained by trying to build the initial version of the product. So for us, I think the first step we took was to take a long break and just brainstorm. Where exactly they went wrong in the first time, and then how exactly we are going to break this down and pick our technology so that this doesn't happen.
I think figuring out the architecture was itself a challenge, because that was just a bunch of AWS instances just sitting there.
The first thing I did was to
shut
down the instances. I saved you guys $2,000. So once that's done, the shutting down. Shutdown. Step 2 was we sort of broke down this problem into 2 sections. It is true that we had to do real-time streaming and we had to do real-time transcription, but each on its own is a different problem. So real-time streaming, we wanted to check to solve that first, and then we looked at different WebRTC solutions because obviously WebRTC is the way to navigate for this. So we looked at on-prem solutions, having our own media server, peer-to-peer solutions, and hosted solutions. And then we went with the hosted solution, but there are implications in other areas as well.
Yeah, I think so. We specifically looked at WebRTC, whether going on our implementation or using a managed implementation. It had to be WebRTC because one thing is there had to be two-way communication, right? While I'm doing my podcast or my stream, my listeners could also call in and express their ideas.
Exactly, yeah. So if it wasn't for two-way communication, we could have easily gone with something that just broadcasts a stream and then that gets broadcasted. But in this, it was a very tricky situation. In here, I think the requirement was that exactly 6 people can communicate at a time and nothing more. So that's the way we structured. I think we decided to go with Agora, which was the best available option at that point. But I think considering the huge lack of documentation, I wouldn't really go in that path again if I have to do it, in 2020.
Yeah, but I think it's a common scenario for all the different streaming solutions because we work with AWS Times. And then what do you call talkbox?
But the Vonage.
Vonage. Yeah.
So interestingly, Vonage have really well documented the documentation and all, but I think the price point is a bit higher than your regular service. And then there's a few new players as well. But when it comes to latency, I think Agora is a bit mature because
I think they have a global network of servers where they reduce the latency quite.
They live in the edge as well. Okay, so we picked Agora. So we got part of the problem resolved by using Agora and pairing it with the correct the signaling server. So initially, I think we had ideas of going with our usual liking for Python Django backends. We were thinking a Django backend, but we realized that this is a IO heavy thing that going to service a lot of requests to initialize these connections with the clients. So I think we went with the Node backend, which was also a critical decision at that point.
Yeah. So I think Node was an interesting choice because given that our liking, so as a company, we always prefer Python because we work with a lot of MVPs where we had to get out the MVP really soon. So Python Django helps us a great deal. But in this case, we had to go with Node because of its nature to quite handle the IO related operations. So it's not because of front end guys can come and do back end on their spare time. I think that was the more case for most people. But in our case, we had a legit engineering use case. So
it was a conscious decision, not
And to clear out something, was it the signaling server or was it just the server that communicates with Agora and Agora has the signaling server? I'm not sure.
Actually, I think you're right. I think we the backend was only creating the communication, the token authentication we have of
Actually,
Agora.
we have to keep the tokens somewhere hidden, so we use a backend. But our backend talks to the Agora services and they handle the signaling part.
So like that, we got the streaming part configured, and then we have a stable streaming service that we tested it out and it was working quite well. And then we came down to the transcription part, which was the tricky part.
So before we go into that, I think we might have to mention that how the scalability was handled. I think we didn't even have to think about that. Is that the case? Agora just went ahead and handled everything.
That's right. So I do remember in one specific instance we were rolling out this product. They asked us to let them know beforehand so that they can be prepared to load balance if it comes to that.
Yeah, so even they had to be prepared for that kind of scalability.
Right.
Given that they actually do handle things at scale. I think, as I know, they are the underlying platform for Clubhouse as well. So they know how to work with these kind of things, but even they need to be prepared, right?
That's right.
Another thing that I wanted to ask you is that usually WebRTC has this different kind of topologies, and we have to configure it to match our requirement. So usually it's a peer-to-peer one, but as you scale, you can't work with peer-to-peer because one device.
Your device can't be broadcasting it to 100,000 people.
There's a limit to how much connections you can manage. So you have to kind of relay through a media server. So I think that's automatically managed through Agora.
Through Agora, So Agora essentially acts as a media server. Our stream goes to them. They broadcast it back to all the connected peers. I think the price point is very fairly well okay for the services they provide.
Us doing it ourselves would have been a nightmare, right?
Yes.
Maintaining all the media servers, signaling servers.
That would be a disaster. That would rack up the AWS bills sooner than
again, the startup is back.
Yeah. So like that, we handled the streaming part, and then we came to the transcription part. So the thing about transcription was how they handled transcription earlier. So these are live streams, right? So to transcribe a live stream, it's not like transcribing an offline stream or let's say a podcast, which is you already have the file and you send it through a transcription mechanism. Rather, the key differentiation is that you have to have a thread, or I would say a computer, always listen to this audio stream so that it doesn't miss anything. It's like a human. It's like having someone listen to the audio stream and write it down.
Exactly. You cannot stop, right? You constantly has to listen.
Yeah.
That's the whole point of
it. So earlier, the way they have done was they have figured out that was a requirement. Like you have to have a node listening to each and every source,
And
then
they just did that.
they just did that, and then they got that audio stream, and they have, which is like running 24/7. You have to pay for your AWS bills for transcriptions, and it was like that's how they get to bankruptcy in the first instance. So what we did was we looked at this and we realized that one part, like these listener nodes, the parts where like the instances that's listening to these streams, we cannot get rid of that. We have to have it. We can make it more efficient. That's the only thing we can do.
So this was actually the quite tricky part. If you take transcription and the live streaming and the transcription two parts. The transcription part was the one that was occurring a lot of costs. Relatively. The other one was just about deciding what we are going with and picking the right service.
This
was the most challenging
piece of engineering. So as a result, what we did was we split this process into two. Like the nodes that listen, the computers that listen to the stream. That's like one set of nodes, and then the nodes that actually do the work of transcribing. And then we, instead of using AWS Transcribe, we went with there's this open source model called Deep Search. So before Whisper and all the advantages of like the OpenAI things came up, Deep Search from Mozilla was the state of the art. So we use Deep Search in one of the transcriber nodes. So we have two types of nodes: the listener nodes, and then we have the transcriber nodes. Listener nodes, they just have to listen to streams, right? So they are very low power. You can map it to like a AWS T2 micro nano instance.
Smallest one,
whatever the smallest one available. We did a bit of optimization rather than going for one CPU core. So we went for two.
So the smallest one is actually free, right?
Yeah.
Can you spin up hundreds of free ones?
You get around. I think you only get around the cumulative 750 hours of free.
Oh, okay.
If not, it's going to be abused. I can get cluster out of the videos and call it a day. So we got these small ones with just 2 CPU cores, and since it has 2 CPU cores, it can listen to 2 streams at the same time. And then these were doing nothing, just just recording the streams into 10-second chunks and putting it into a S3 bucket.
Yeah. So they just input is at audio and output is actually audio chunks. It just doesn't do anything.
At all.
Yeah. And you have to split it into chunks to be able to process it.
Yeah, it was like a sweet spot. We realized that 10 seconds is the sweet spot where we can match up network latencies, transcription delays, and everything. And that was
just a trial and error thing where we figured out 10 seconds.
10 seconds is the optimal one. And then there's another set of services like the nodes, the transcription nodes with the deep speech model. Those are a big computation heavy instances like your T2 X large kind of models instances, and those.
What's the window for the index? Is it 10 seconds or is it more than that?
The searchable window was actually 1 minute, 60 seconds. And then we realized that the overall propagation delay from recording to a transcription was less than 2 seconds, if I'm right. So
it had to be, right?
It had to be. That we had to have that delay. That was the one option. So overall, this was the architecture we came up, and then the initial cost they had for transcribing one real-time audio source was around $2,000 per month, and we brought it down to around $20 per month per stream.
Wow.
So they would run.
That's crazy, right?
Yeah, that's just crazy.
I mean, if you look at it, you still have a bunch of instances running.
Yes.
And you still have this heavy weight being done. Heavy weight work being done.
Yeah.
But the
100th of the cost.
It's crazy, right?
It's just taking that engineering decision of splitting the things and using open source.
So I think we earlier mentioned that having this distributed multiple instances of in AWS is quite difficult to manage, right? So I mean, now that we are in this position, now again we have a set of instances, right?
We can give you from this particular episode.
From all our experiences, what the best advice we can give you is that you probably do not need Kubernetes.
Yeah. We went with we had around 200 instances running, and we went with Docker Swarm. Docker Swarm worked brilliantly. We didn't have to have 5 different nodes just to schedule the work like in Kubernetes. We just spin up one master node where we run in Docker Swarm, and then it was orchestrating the rest of it.
Can can the Docker swarm sits out in a separate
It
instances and spin up more instances?
It can.
Okay.
So technically it cannot spin up instances. What it can do is, but with a bit of engineering, we can make it automatically spin up. What we use Terraform. So Terraform handles the infrastructure setup, infrastructure orchestration. Docker handles the instance orchestration, and then we put together.
I honestly thought Docker Swarm was only to handle the it can only run within an instance, and its scope is limited to an instance.
Yeah,
it can manage instances from the outside.
Absolutely. Because Docker has this concept of overlay networks, where inside a network you can create an overlay network that is a sort of virtual networks, but you can add nodes from anywhere. And then as long as those nodes can talk to each other over the overlay, you can have your swarm running and operating without any problems.
Cool. That's a really good insight for me personally. And what about Docker Compose? Is it same as Docker Swarm, or do you pick among that?
Docker Compose is, as you said, mostly for a single instance. Yeah.
Okay.
But the Swarm, the stack config is similar to Docker Compose config. I think that was a conscious decision from Docker itself. It was mostly to run things internally.
Yeah. But I think compared to Kubernetes, Docker Swarm is insanely simple.
Insanely cheap as well, because much less nodes we have to run.
I think you have to run a huge instance to be enabled to run Kubernetes, which is not very good.
And it's just for no reason you are making things complex, right? We recently took over a project, a very basic community management platform. The first thing I noticed was it was on GCP, red flag 1. And the second thing we noticed was that it's running Kubernetes. Just one instance server running Kubernetes. I don't know why. And then there's
just a content management, right?
Just a content management platform. And you don't even I just put it in a VPS. You don't even need a cloud provider if you're running a content management system. So with this, we dropped down their costing to 100-fold, and then we got the app out in a fairly tight schedule within around 4 months. And the app is out there. We won't be disclosing the app at this point, but it's out there and already have a few thousand listeners as well.
I think maybe we could have done. Maybe we could done one of these in the platform itself, because it allows private podcasts. So maybe
actually yes,
we should think about that.
Maybe the podcast will go live next in the in the platform itself.
I think one of the challenges that we didn't mention was to actually convince the customer to abandon his earlier setup and rebuild the thing, because I think that's something common in founders. They kind of
get attached.
And that's a common what do you call this fallacy, the sunk cost fallacy.
Yes,
where you just made an investment and you stick to that without being afraid to move on. But I think in the long run it gets you in a better position.
Absolutely. All right, so that comes to the conclusion of our second episode of the 2 Bits podcast, where we discussed, dissected, and analyzed the challenges in real-time audio streaming and transcription. We went through a case study of how we handled it to one of our clients and how you could do it with potentially with a fraction of the cost you would be doing it right now. If you have any questions, you can always ping us, and then we can get into a call to have a consultation. If not, let's see you guys again. Stay tuned with the 2 Bits podcast.
So see you guys in another episode.